Hey, sixth grade math students. Whoa, Mango here, and maybe just me, would like to show you how to do a new unit. We're going to talk about functions and tables. Functions and tables. This is a return to algebra, a return to the things that we were talking about in algebra, but we're going to take it to the next step. We're going to do a little bit of solving equations, but really what we're going to look at is what do equations show us? And, I've gotten the question in the past, or actually recently, how does any of this, why will I need to do any of this in real life? Well, functions and tables are one of the things, I think, that we use most often. But a lot of times we just do them in our heads. We just figure it out and we just make the pattern in our head. So what we're going to do now is practice writing it down and being able to notice the patterns. All right, so let's talk about it. Beginning functions and tables. What does this mean? All right, let's look at a problem. The Mavis Car Company charges $15 per day plus 18 cents a mile when they rent cars. What is the charge for a one-day rental that is driven 50 miles, 70 miles, 121 miles, or n miles? Remember, n meaning some number of miles. Well, the first thing we need to do is look at this through the language of algebra. And we looked at the language of algebra. We did some practice of turning English into the language of algebra. So let's look at this. I have $15 per day plus 18 cents a mile when they rent cars. That means for every 1 mile, it's going to charge me 18 cents. But then it's also going to charge me $15, just a flat fee of $15. So whatever I get is I'm going to have $15 plus the other pieces. So let's start with just this first one. Let's just talk about this first one. The first one is going to be 18 cents a mile times 50 miles plus $15. So that is $15 per day plus 18 cents per mile times 50 miles. So that's $15 plus 18 cents times 50. 18 cents times 50, that's $9. 0.18 times 50. So now I have 15 plus $9, so the trip is going to cost me $9, and then the $15 for the fee. So the total for 50 miles would be $24. Okay, great, but what about the others? Because when we're talking about functions, and we're talking about tables, and we're talking about graphs, what we really do is talking about patterns. What if we drive more than 50 miles? We might want to limit how far we drive based on the costs. We might say, I'll drive this far, but I won't drive that far because it's much, much, much too expensive. So let's look at more. The $50 or the 50-mile trip would cost us $24. Let's look at the others. Now, let's look at 70 miles. The equation is the same. The problem is set up the same. It's still $15 per day plus 18 cents per mile times 70 miles. So 0.18 times 70, that gets me $12.60, 12.6. Add those together and I get $27.60. What about 121 miles? Well, same thing. 0.18 times 121 gives me 2178 plus the 15 gives me 3678. So you can see I'm starting to develop a pattern of a list of those numbers as we go. What about n? Well, n stands for some number of miles, some unknown number of miles. But we've created a pattern here, haven't we? Our first one was $15 plus 18 cents times 50. Our second one was $15 plus 18 cents times 70. Our third one was $15 plus 18 cents times 121. What is the thing that is changing? What is the thing that is changing in each one of these? Well, the $15, that's the same. The plus, that's the same. The 0.18, that's the same. The times, that's the same. This is the number that changes. Another word for change is to vary. So what we call these is the variable, the thing that changes. So what we can do is we can substitute any one of these numbers with our n. So we can say, well, however many miles you go, you're going to multiply that by 0.18, and then you're going to add it to 15. So this right here is our rule. This is our function. Now, so $15 plus 0.18n. That would actually make more sense, wouldn't it? All right, let's look at another example here. But this time we're going to look at the pattern involved. I'm going to give you the equation, and let's see if we can figure out the answer to this equation. So Belinda owns a hair salon. She's got to pay rent. She has to pay to rent the building. She has to pay to heat it. She has to pay electricity. She's got a lot of expenses in order to do the hair salon. So she comes up with an equation that shows her how much profit she will make each day. The N stands for the number of customers she has per day. So this will tell her how many people do I have to cut their hair for in order to make any money. So her profit is 18 times N minus 72. So the minus 72 is how much she has to pay each day to run the building. And then the 18 is how much does she charge each person. So we want to know how many people does she have to have in order to make any money. So how many customers does she have to have in order to make a profit? Okay, now we could solve this one way with setting it to 0 and doing our steps, but I want to show you another way to do it. We're going to set up a table. What I mean by a table is I mean a table like this, where we're going to look at the pattern involved. You remember this as in and out tables from everyday math when you were working in the younger grades. So when she has 0 customers, we can put in the equation and we can put in 0 for our N. So this is what it would look like. N would go here. So the number of customers in this case is 0 customers. She sits there all day, no customers come in, she doesn't do anything. How much money is she going to make? Well, 18 times 0, that's 0, minus 72, that would be negative $72. So she loses $72 if she doesn't have any customers. Okay, how about 1 customer? Is she still going to lose money? Well, let's see. 1 customer would be 18 times 1 minus 72. That would be negative $54. Not as bad, but she's still losing money. How about 2? 2 customers would be negative $36. We're getting there. There is definitely a pattern going up. Oh, 18 times 3, that's going to be negative 18. Oh, we're close. Now, what do we notice about these numbers here? I notice that these numbers, each time we go up, they're going up by 18. So I can actually make a prediction. She goes up by 18, up by 18, up by 18. And that makes sense because every time she gets a customer, it goes up. She gets 18 more dollars. So let's make a prediction. If she's at negative $18, I'm going to predict that the fourth one, 18 times 4, the fourth customer, minus 72, is going to make her $0. So she has to cut the hair of 4 people just to make $0. That's rough, but that's how a lot of businesses work. You have to cover your expenses, which means you have to sell or do so many things in order to make up the losses that you'd have if you did nothing. So 0 may seem bad, but at least it's not negative 72. So here's the question. Is she making a profit yet? No, she's not making a profit. She's breaking even, but she's not making a profit. But from here on out, every customer she gets is going to give her a profit. So 5 times 18 minus 72, that's going to be 18. So how many customers does she have to have in order to make a profit? Well, she has to have 5 customers in a day. And if she does that, she'll make $18. Okay, we can keep going. We can keep going and find out how many is 6. It's going to be a pattern. Remember, it's going to go up by 18 each time. And so that pattern is really easy to predict. These numbers are really easy to predict. You'll notice that they're just a mirror of each other. But we can also make big jumps. So in this case, I could go to 10 customers. What is she going to make if she does 10 customers? Well, that would be 18 times 10, that'd be 180, minus 72, that'd be $108. What about 25 customers? 25 customers would be 18 times 25, which would be, I don't know, a big number, minus 72. Whoa, $378. That's pretty good, but she has to cut the hair of 25 people in order to get that far. So for today's assignment, I'm going to give you some functions. I'm going to ask you to make a table just like this. I'm also going to give you some problems, and I'm going to ask you to find the function that's involved. So this is our beginning step. It may seem like a lot of work, but it's really not. Once you spot the pattern, it's pretty easy to predict what all of these are. So it's a matter of taking the equation, putting it in there, taking our number, our variable, and putting it into the right spot, and then just solving for how much it is. All right, good luck.